Okay, hello everyone, welcome to CSCE 642, Reinforcement Learning and Deep Reinforcement Learning. I'm the instructor, Guni Sharon, and our lovely TA.
Hi, my name is Vaibhav Bajaj and I'll be assisting Dr. Sharon with this course.
Yep. Okay, so let's get started. Oops, can you see the screen? Okay. So, first of all, we have the course website where you'll be able to find the syllabus, the schedule, the lecture slides and recording, assignments, project instruction, and the course policies. Let me just quickly show you the course website. You can see it here. Okay, so this is our course website. You'll have the course description. You'll have the information regarding the instructor, the office hours, and the TA. Of course, this might change per semester basis. And you'll have, again, the office hours and the locations. You'll have the schedule of the course, the lecture slides and recordings, these recordings. The assignments are all available here, including some instructions. So for each one of the algorithms you're going to implement, you have the instructions here. Then we have the project instructions. The project is also divided into several sections, and the course policies are available here, also on the website. Finally, the quizzes. You'll have some online quizzes. Second. There we are. So online quizzes and the submission of the assignments and the projects will be through our Canvas website. Okay, so again, the link is available here on the slides. Course staff, again, this will be updated on the course website. Is myself, and we'll have a TA that is assigned per semester. General questions and comments, as well as discussions, should be posted on the discussion board, on the course's discussion board, and notes. So general questions, don't send those to us, either by email, but please post your general questions on the discussion board. This will usually be through Campus Wire, and the link to our discussion board for this instance will be available in the course website. Okay, it will be updated there on the course website. In case you cannot make our office hours, the one that we'll publish on the website, you are more than welcome to send us an email and request for different times. But please try to designate at least 3 times during the week that you are available, and we'll try to set up accordingly. Finally, please allow us some time to answer your questions. So say up to 3 business days. Okay, sometimes we have it the last submission day for some assignments. People are asking a lot of questions and they want an answer now, like an hour before the submission. So that's not always available. Please ask your questions in advance, of course. Okay, the textbook that we're going to follow is the Reinforcement Learning and Introduction book by Stratton and Burton, at least until we get to the deep learning algorithms. The PDF for the textbook is available on our website. I don't know if I showed you. Let me quickly show you where to find that. So this will be here on the right. Okay, you see the textbooks here. You'll have several textbooks. They are all relevant for the course. PDF version is available here. Continuing. Okay, some prerequisites for this course. These are not official prerequisites. That is, we won't. You'll still be able to register to the course. We won't test those, but for the sake of your success in this course, we highly recommend that you follow these recommended backgrounds. So this will be proficiency in Python. So all of the course assignments will be in Python. Please make sure that you have the relevant background in Python. If not, that's still probably okay. Python is actually pretty intuitive to understand and to follow. So simply try to follow. Actually, also if you do have some background in Python, I highly suggest following an online tutorial just to see that your background knowledge is sufficient. So I added a link here to a good tutorial. Please go over all of the topics under Python tutorial, Python NumPy, and it will also be beneficial for you to go under topics under machine learning, though not super crucial. If you see that you can easily follow the Python tutorial and Python NumPy, you should be good. Next, it would be beneficial for you to have college level calculus and linear algebra background. So if you still have a good memory of your undergraduate course on those topics, you should be fine. However, if you need to refresh your memory on those topics, please follow the playlist, the YouTube playlist that I linked here. It gives you a good refreshment for these topics, right? And you should be fairly comfortable with everything discussed in these videos. Also, you need some relevant background in basic probability and statistics. Again, there is some a good playlist that I linked here that should give you a good refreshment for the required background knowledge. And again, you did go over these topics in your undergraduate, or you should have. Hopefully you did. Finally, foundations of machine learning. This will be very helpful. Specifically, when I'm talking about foundation in machine learning, I'm mainly talking about supervised learning. We will use many of the supervising learning techniques, mostly later on when we discuss deep RL. So it would be useful for you to go over these topics. It's not super crucial because I will cover this. We will cover the basics of these, but I'll try to do it fairly quickly. So it will be beneficial for you if you have some background knowledge there before we get there. Finally, I included the list of relevant courses here in Texas A&M. If you went over all of these courses, or if you took all of these courses recently, then you should be fine. Okay, so all of these courses should cover all of the relevant background for this course. Okay, so a large portion of the grade in our course will be given for the programming assignments, mainly because these will determine how practical what you learn in this course is for you to later on implement RL techniques and be able to use those, right, in any domain. So you will implement several RL algorithms. Again, you can already go onto the course website and see all of the algorithms that you're going to implement. You will be graded separately on each of the algorithms. Please note that not all of the assignments bear the same weight in the final grade. Submissions should be done individually. So each of you will have your own implementation of these algorithms. Please don't copy, don't cheat, don't copy the code from fellow students or from fellow students that previously took this course, because we will use plagiarism detection software, right? Specifically the MOS server from Stanford. It's pretty good. I wouldn't test it, right? Don't put it to the test. It can actually go deeper than just see if you copied any of the text, but it can actually go deeper and see if you have overlapping logic. Of course, low-level logic, right? If you just go and change some of the variables' names, it will detect it. I highly recommend against trying that, and in any case, I highly recommend you to implement the algorithms by yourself, because that's in essence what the main takeaway from this course, right? That you'll have the ability to implement RL solutions to different domains. Finally, the assignments are based on the OpenAI Gymnasium API, so it would be very useful to follow the tutorial discussing this API. Again, I provide the link here. We have all of the assignments belong to the same code base. This is something that should be very helpful for you guys. And all of the algorithms, all of the classes within the same code base, they extend the same abstract class, the same abstract RL solver. So this should be very easy for you or help you a lot to streamline the assignment process. That is, for each assignment, you don't need to download a new code base and install new dependencies. You'll set it up once and then you can just implement one class at a time. And for the submission, you'll just implement each one of the classes that you recently implemented. You just submit that file.
Professor, is there any computational requirements for the course?
So you are not. So none of the assignments will require you to run your solutions on or to test your solutions on any vision-based reinforcement learning. So if your state space is defined by some images, for instance, by playing video games, or if you implement a reinforcement learning agent to play, for instance, Atari video games, solving such problems are usually heavier on the computation. They require a decent GPU to run in to have a reasonable runtime. However, we will not require you to run any of those, to run on any such domain. However, right, in any case, your implementation are general, so in essence, they could work on optimizing an Atari controller, or video games, or an autonomous car driving, or anything that is vision-based. However, we don't require you to evaluate your solutions on those type of domain because it might take too long. Now, for your final project, I'll discuss that in a second, you might choose to implement an RL algorithm or to test an RL algorithm for a unique domain, something that might be related to your own research, that does require image processing. In those cases, so for your final project, you might require some more powerful hardware, GPUs. If you don't have access to those and you would like to take on a final project that requires those type of resources, feel free to contact us, the core staff, me or the TA, and we'll try to get you access to relevant resources. No promises, but we'll do our best. Okay, so the main weight of your final grade will be the final project. Your final project can take one of two forms. Either it will be a practical implementation of an RL algorithms in a domain of your choice. So we usually recommend to tie that into your own research. So most of you are graduate students. If you have your own research topic, we highly recommend that you'll find a relevant RL problem within your research topic and try to tie your final project with your, as I said, with your the domain that you are researching. This is highly recommended because it might mean that your project is a bit more involved, it might require more efforts, but you're not wasting your time, right? In some sense. I mean, in any case, you won't waste your time, but it will actually also advance your own research and your own graduate degree towards your own dissertation. So you can implement existing RL solutions in your domain of choice, and then run some empirical evaluation and report the results. That's how most final projects are performed. Another type of final project will be a theoretical one. That's also a possibility, although a less common one, but it's also a pretty high impact, it might be a high impact project, where you propose an interesting enhancement or an interesting variant of an existing RL algorithm, and you change the learning rate or make something adaptive. I mean, once we go over the algorithms, you'll see that you can play with a lot of levers and buttons there. So you can suggest a unique way to do that. And then you can have an empirical study where you try to check where this improvement or this enhancement helps, this variant helps, and in what domain it doesn't help, and if you can somehow assess why that's the case, or you can explain why we see the results that we see, that would be great, right?
Professor,
yeah.
Will the students be provided any project ideas to choose from?
Right. So if you have if you don't have any specific idea or specific domain that you would like to work on for your final project, you're more than welcome to contact me or the TA, and we're more than happy to guide you toward high impact projects. So in our lab, we have the PhD students are always involved in some very interesting RL projects, and at any point of time they have more interesting sub-projects that you might want to pursue, and the TA can help you get in touch with the relevant students and projects. So definitely we have some potentially high impact projects, and you're more than welcome to discuss those or to ask us about those. So the project grade is partitioned as follows. So the project proposal, this is usually due towards the middle of the semester. That will be exactly 5% of your final grade. The literature survey due later would be 10% of your final grade. Then the final project is usually due at the end of the semester. It will be 35% of your grade, and it's also a further partition as follow. You'll submit your source code. That will be an in the sense. So both the source code and an executable if one is required, as well as a README file telling us how to rerun your experiments, and maybe explaining the code. So this will be 5% you'll be graded 5% of your final grade based on your code. Then you'll also include the 5 minutes MP4 YouTube video. You'll just upload it to YouTube. That will be 10%. So your YouTube video will provide some high-level description of your project and the results. You'll get that will be graded at 10% of the final grade. And finally, you'll submit a detailed written report in the form of a scientific publication that will be describing, of course, your project, the results, and your takeaways. That will be 20% of your final grade. Late submission policy. So in total, you have 6 late days that you can use. It's up to you to use. We won't check. Right, you just have to say that you're using a late day, and that's fine. A late day extends the deadline by 24 hours. You are allowed up to 2 late days per assignment. If you hand in an assignment after 48 hours, it will be worth 50%. No credit will be given to assignments handed in after 72 hours. You can use late days on the project proposals. This will be up to 2 late days. And the literature survey up to 2 days. No late days are allowed for the final project submission. This is because the final project submission is usually at the end of the semester, and we have a tight schedule with respect to the final grades. So we actually cannot allow late days for the final submission. Any late days on the final submission will decrease the potential score on the project by 25%. You should use your late days only for approved reasons, right? You can refer to student rule number 7 for information about excused absences. The reason I'm saying that is because if for some reason you need a seventh late days, right, and you have an excused reasons, at that point we will ask for documentation showing the excused reason for all of the days, for the original 6 days, and then also for the extra late days that you require. So in any case, please just use the late days appropriately. So finally, 10% of their grades will be given for online quizzes. These will be short, about 15 minutes. It can be a bit more, a bit less, depending on the number of questions. And these quizzes, a quiz will be provided at the end of each topic. These will be online quizzes available through Canvas. You'll have about a week to finish each one of the quizzes at your own time. But once you start a quiz, you'll have the timer will start and you'll have about 15 minutes to finish it. Every semester I have some issues with students saying, oh yeah, I started and then I went to have lunch and I forgot about it. So no, just be aware that once you start the quiz, you have a timer and you have to complete the quiz within some within some time bound. The quizzes will mostly be composed of multiple choice questions, just for them to be easy enough. They won't be super difficult. I mean, they're mainly not for us to assess how well you're following the material, but mostly for you guys to be able to assess if you are appropriately following the course, right? So you can see, again, it's only 10% of your grade. It won't really change your final, probably won't change your final grade, but it will allow you to get a feeling if you are, well, correctly following the course, or maybe you should follow it a bit more closely.